Hello and welcome to this presentation about EFMrep, which is an extension of the Eurofmix model in order to combine mixed profiles from different kits. An overview here is that it enables the combination of different kinds of samples, both from the same and different DNA extracts. Importantly, it can also evaluate multiple profiles evaluated with different kits. What's important to understand is that across all samples, the model assumes identical proposition sets for all these samples. That means it considers the same. It assumes that it's the same contributors across all samples. It's possible to define kinships for the unknowns in the hypothesis, and also the tool supports that there are it's a large number of samples that is combined, but of course that can take more computational time to run. We have wrapped the model into a GUI, which is available to download from the online. Here are also tutorials available. So you can go ahead and install it, and also you can view the source code on GitHub. A quick view how to install and how to run the program, and also it's useful to see how that projects can be saved as a file when you are doing your analysis in this tool, and you can open the project again after you have closed the program. So I will now show you a motivating example as a demo. Now consider the situation we have two Fusion 6C profiles, and also sample was run with ESX17. So we also have such a profile, but with a different kit. We have imported these three profiles into the program. They are stain 97, stain 44, and stain 96. So what we have done in this program now is to specify which kit each of these profiles has been analyzed with. Additionally, we also have imported two reference profiles. Last, we have also included or imported frequency file, which covers all the markers of these kits. What is useful at this moment is to give an overview of the mismatches between the references and each of these samples. That can the GUI give you. In this example, we are interested in evaluating the LR for ref2, where we assume two contributors. So what we obtain when we evaluate the ESX17 and the Fusion 6C profile separately is these values here. Log LR of 14 on the log 10 scale and 17 for the Fusion 6C files. And the model validation went okay. So what should we report from this? So these numbers here in the GUI, they are useful to put similar to indicate which replicates can be put together, same as in Eurofmix. And it also helps to fill out the kit and settings more quickly. Okay, we go now to the most difficult part of the program, which is how to specify the model. So in this panel here, each column represent a parameter type. So the first column is mixture proportion, the second and third are peak height expectation and peak height variability. If you remember EFMrep, these are parameters part of the EFMrep. Also in EFMrep you need to decide if degradation should be turned on or off, and also if back stutter or forward stutter should be used. So what is confusing here is of course the numbers. What do they represent? So importantly, these numbers represent which parameters should be shared across the samples. So here we have one for ESX17 and two for the Fusion 6C profiles. And that means that they should have separate parameters for these two different kits. This is also set the same for peak height expectation, peak height variation, and also the degradation. For the backward stutter, however, we have assumed that these are all shared across all the three profiles. And we have turned off forward stutters. This represented by 0. We now go back to the example, and what we got here as a result was LR of almost 21 on the log 10 scale. And also the model validation went okay. We have published a paper about EFMrep, which is of course online. There is also data available online, which were used in this paper. You can download those. So here is one example from the paper, which mainly evaluated data from the proved-it dataset, where we harvested samples with the same contributors inside, but analyzed with different kits and also with different characteristics. So in this example, we have three different kits for these 4 profiles. So when you are interested in calculating the LR for Ref29 here, which is a minor contributor for all these samples. And we also notice there's a high number of dropouts, and the mixture proportions are not very high, and the LR is also not very high when each sample is evaluated separately. You can download this data from the shared folder. So this figure shows how the calculated LR when combining different samples. So what we obtained when combining all the 4 samples was the highest LR of almost more than 17. And so the number of combined samples increased the LR. And the opposite trend was observed for the non-contributors. We can see from these distribution curves, these cumulative distributions, that the distributions are more far away the more samples that are combined. I will now go into the real case example, which was also in the paper. So in 2019, a juvenile was brutally raped and she became pregnant. Following an abortion, a sample from the womb of the victim was collected and sent to the DNA lab for analysis. So the aim here was to carry out DNA profiling of the samples to provide information about who was the father. So in this example, we got 6 DNA profiles, sample A to F, all evaluated as a global filer kit, except of sample C, which was retyped using the Fusion kit. So we used EFMrep to do the convolution of the sample profiles in order to get the best estimate of the genotype profile of the unborn child. Yeah, the last sample C was re-evaluated, yes. So here is the GUI where all the samples are imported, and we have also imported the victim profile. So now we can see from the GUI here that in practice it is possible to import a lot of samples into the program and evaluate these simultaneously, but of course there are computational extra cost to do this. You can now, from this point of view, do either LR calculations or deconvolution. So in this example, we did deconvolution. And also this dataset is available in the shared folder. So the model specification for this example, we see that we select different parameters for each of the samples. And there was one sample which did not show any degradation, and this was turned off for the retyped sample fusion sample. And no stutter was assumed for these samples. Additionally, we assume that one of the unknowns is a child of the victim. And we assume 2 contributors. As a result, we obtain a lot of different parameter estimates. In total, 27 were optimized simultaneously. And this is the output in a text format, which you can show the estimates for each samples. The deconvolution result looks like this. You get the top candidate genotype of the unknowns. The victim profile was conditional, and hence no uncertainty around that profile of those genotypes. But for the unknown, these are the most likely ones. And we can see that the combination of so many samples here helps to increase the probabilities for the top ranked genotype. We can also see that for the fusion markers, these are based only on one profile, and hence the probabilities are also lower. And as a conclusion, EFMrep is an extension of EFMrep's model to combine SDR DNA profiles to run with different multiplex kits. The tool is included as a GUI to ease the analysis for practitioners. The proved-it dataset is useful to show the benefit of combining samples with different properties, analyzed with either the same or different multiplex kits. EFMrep is very useful for real casework since samples extracted from the same material can have different properties, especially when analyzed with different multiplex kits. We have illustrated this with a real casework example. So I want to make some note on the implementation, how it's currently implemented, and what are future plans. The current implementation is now quite outdated compared to the current version of EFMrep, which has improved during the last years. So for EFMrep, 3-person mixture is manageable. It will take a lot of minutes. 4-person mixture will take a long time, and 5-person mixture is not possible. It will take too long time. Of course, these times also depend on how many samples you include and how the samples look like. So there is a need to do an updated implementation where the new algorithm of EFMrep is utilized. This is on the to-do list, but it's not heavily prioritized. It will take a lot of effort to actually reach the same speed as EFMrep. Since EFMrep now, with 4-person mixer, can be analyzed in at most a few minutes, and 5-person mixers can be calculated in a few hours.